Welcome, viewers, to Senior Study Class on Tech TV. I am Peter Boache, commonly known as Most Senior, your mathematics instructor. Today, we are going to consider another interesting topic in mathematics, and that is coordinate geometry. We sometimes find distances between towns, communities, and countries. You will need the idea or the knowledge of coordinate geometry. It's so interesting, and I hope by the end of the lesson you shall enjoy the whole concept and you play with it. Viewers, at the end of the lesson, you should be able to find the distance between 2 points. 2. You should be able to find the gradient of a line. So today, we have only two objectives. 1, to find the distance between 2 points, and then 2, to find the gradient of a line. And I hope you will enjoy the whole concept. So, we shall begin with distance between 2 points. In our previous discussion, we learned how to plot points in a 2D plane or 3D plane. That if you have an example like a point P, 2, 4, and you are plotting this point on the OXY plane, it simply implies that the first coordinate, which is 2, that's the x coordinate, implies move 2 steps to the right because it's positive. And so we shall move 2 steps to the right, 1, and then 2 to the right. The second coordinate is a positive number 4. And so it simply implies that move up the y-axis 4 times. So you know already that when the number is negative on the x-axis, you move to the left. If it is positive on the x-axis, you move to the right. Positive for the y-axis, you move up the y. And then negative, you move down the y. So plotting 2, 4, you will have to move 2 steps to the right and then 4 steps up to get the point 2, 4. That's how we plot points. But then today, we are going to consider how to find distances between 2 points. If you have any given 2 points, how do we find for the distance between them? Like I used to say, I believe in understanding the concept so that you can apply it anywhere you go. And so we shall all together develop or derive the formula for finding distances between 2 points. Let's consider a normal OXY plane like this. Every point has got 2 coordinates, the x coordinate and the y coordinate. So when I trace the point A to the x-axis, I have the x coordinate. Let me label that as x1. Then I will trace the A to the y-axis. I have the y coordinate. Let me label that as y1. I can't label this as x1 and that as y2 because x1 corresponds to y1. Let's go for another point in the same plane. Let's say point B. Point B. When I trace the point B to the x-axis, I have an x coordinate there. I want to label that one as x2. Same way, if you trace the B to the y-axis, you have the y coordinate there as y2. So realize that in the plane we have 2 points. Point A, the coordinates are x1, y1. At the point B, the coordinates are x2, y2. We need the distance between the point A and B. The point A and B. And so, we shall try to find the distance. But note this one. Anytime you have a right angle triangle, two things come to mind. That is the trig ratios or the Pythagoras theorem. We are now going to apply the theorem, which says that the length of the longest side, the square of that, is always equal to the sum of the squares of the two adjacent sides. In this case, let me label this point here as C, so that we will have triangle ABC. Triangle ABC. By the theorem, we have AB squared, the longest side squared, should be equal to BC squared plus AC squared. They are both lengths, so we have to come with my magnitude sign. We have AB squared is equal to BC squared plus AC squared. Now, in finding for the distance between the B and the C, which is the same as what we did earlier on, we have A, we have B. So A is x1, y1, then B x2, y2. When you check the distance between the C and the B, it is the same distance between x1 and y1. So you find for the distance between x1 and y1, it is equal to x2 minus x1. Distance between x1 and x2 is equal to x2 minus x1. And the distance between y1 and then y2, obviously you can tell it. What is it? y2 minus y1. So in place of the distance between A and B, in place of distance between A and B, we will have AB squared plus BC squared. That is there. AB squared is equal to BC squared plus AC squared. AB squared is equal to BC squared plus AC squared. So now back to the diagram. The BC, this is the C. From B to C, the distance there is x2 minus x1, which means that in place of the BC, I'll write x2 minus x1. Then I will square it because the BC is also squared. In place of the BC, I'll write x2 minus x1. And I will square because the BC is squared. Then I'll bring my plus there. Back to the diagram. Between A and C, the distance is y1, y2, which is the y2 minus y1. You subtract the y1 from the y2. And so you have y2 minus y1. In that case, in place of AC in the formula, I can put y2 minus y1 there. And then because the AC is squared, I have to square y2 minus y1 as well. Remember, our main interest is to find for the magnitude of AB. In other words, the distance between what AB. Therefore, we must get rid of the square of the AB. And we do so by only finding the square root of both sides. So I'll find the square root of this side and the other side as well. And the other side as well. You see, it's becoming interesting. Then the square of the AB will take out the square root. you know that every square root is the same as exponent half. So it will multiply the two and they will cancel out, leaving distance AB to always be equal to x2 minus x1 all squared plus y2 minus y1 all squared. So in just some few seconds or minutes, we have all developed together the distance between 2 points to always be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Note, x2 minus x1 is squared. The square is outside the bracket. y2 minus y1 is squared. The square is also outside the bracket. Again, note that the x2, x1, y2, y1 are all coordinates of a point. They are coordinates of a point. So when you're given any 2 points, all you do is to label the point as x1, y1, x2, y2, and then you're good to go to use the formula in finding for the distance between 2 points. And so we shall try an example by using this simple and nice formula. Example 1. Find the distance between the points A, 2, 4, and B, -1, -2. Let's look at the solution. We are doing it together. We are finding for distance between the point A and B. So I have to write my magnitude sign there to indicate that we are looking for the distance between 2 points. And that should be equal to the formula x2 minus x1 squared plus y2 minus y1 squared, or in a root. Like I said, anytime you are solving or you are finding for the distance between 2 points, you label the coordinates. So the coordinate for A, I will label that as x1 and then y1. And the coordinate for B, I will label that as x2 and then y2. And so now that I have my coordinates, all that I do is to go by the normal substitution. Let's see what we'll get. Now from the coordinate, what is x2? Obviously it is -1. So I'll have -1 minus. My x1 is also 2. So I'll bring my 2 there and then close the bracket and square. Then I'll go for the other coordinate y2. y2 is -2. So I'll bring -2 there minus. Then y1. By inspection, it's what? 4. Then you square. And so we do have to operate those in the bracket. -1 minus 2 will give us -3. So you square that as well. Then -2 minus 4 will give us -6. Then you square that 2 as well. Then when you square -3, the result will be equal to 9. And then when you square -6, the result will be equal to 36. So then your final answer for the length AB should be equal to square root of, let's add 9 plus 36 will give us 45 units. Please, you must always come with your units. If you are finding for distance between 2 points, you can have it as in either meters or centimeters or kilometers. So once the unit is not given to you, please end your answer with units. Root of 45 units. In a simplified form, root 45 becomes same as 3 root 5. 3 root 5 units. 3 root 5 units. You see how so simple it is. Just identify the coordinates, label them as x1, y1, x2, y2. Then you go ahead with the substitution, you simplify, you do the normal operation. Just do the normal operation on them as in their brackets, and then you have the answer as simple as that. Remember, all the time after finding for the magnitude, add the unit to it. It's very, very important. Let's see if we can try the example 2 together. Kofi walks from Tuanse, -2, 5. In this case, Tuanse is a point, to another town in Carrier, 7, 2. So in Carrier 2 also becomes a point. Find the distance between the two towns. So now we know the point of Tuanse and the point of Nkawie. We need the distance between these two towns. Once we have our point there, the first thing we do is to label the coordinate of the point. As usual, x1 for Tuanse, x1, y1. And then for Nkawie, it will be x2, y2. What are we finding for distance between the two towns? We go for the formula that will help us to be able to find for the distance. Now we have two towns. We can take their initials as the point. So I will take T for Tuanse and N for Nkawie. And so I'll write T as -2, 5 and N as 7, 2. Meaning, I'm going to look out for distance between T and N. That is Tn. Tn. What says our formula for finding distance between 2 points? It is always equal to square root of x2 minus x1 squared plus y2 minus y1 all squared. That's the formula. And so once you have the formula and the coordinate known, all you do is you go ahead with your substitution and then find for the distance between the two towns. So obviously by inspection, what is x2? x2 is 7. I want you to do it on your own, and I will give you the final answer to it, just to check that you are okay with the whole concept. x2 is 7. So you have 7 in there. x1 is -2. So that becomes 7 minus -2. Note, when you have two negative signs coming together, it becomes what? Positive. So note that carefully. Then your y2 is given as 2. y1 is also 5. So that becomes 2 minus 5. So after doing everything, then your answer for Tn, the distance between the two towns, must be equal to root of 90, square root of 90 units. In a simplified form, that will be equal to 3 root 10. 3 root 10 units. 3 root 10 units. So if you had it right, then you are good to go. It means that you can find for distance between 2 points at any point in time, at anywhere you go. So all the time, keep the formula in mind. You can also try to recall the steps we went through to develop or derive the formula. That the distance between 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. I hope you have enjoyed this aspect of the lesson. The next thing that we're going to consider will be how to find for the gradient of a line. How to find for the gradient of a line. We can also refer to it as a slope. So when I say gradient, it's the same thing as finding for the slope. The two are the same. And so this one too, we shall try to also develop the whole formula for the gradient. How a given line is sloping. If a line passes through two distinct points, example P1 as x1, y1, and P2, x2, y2, then its slope m is given by the formula m is equal to y2 minus y1 out of x2 minus x1. And this, like I said, is for the principle that the slope of any given line is given by the vertical distance out of the horizontal distance. Vertical distance out of the horizontal distance. So we have to consider OXY plane. So we have a point A with coordinates x1, y1, and a point B with coordinates x2, y2. And so when you consider the vertical distance of the line AB, when you trace them, you have y2 here and then y1 there. And then down there you have x1 and then what? x2. So the vertical distance is between y1 and then y2. And so if I say that m is equal to the vertical distance, which is the same as y2 minus y1 out of the horizontal distance, in this case the same as x2 minus x1, then we are always saying that anytime you have a line and you know of the coordinate of the point joining the line, then you label the point as x1, y1, x2, y2, and use the formula m is equal to y2 minus y1 for the vertical distance out of x2 minus x1. Note, we most of the time denote the gradient by the letter m. So when you see m on the screen, the m represents the gradient of the line. So we are now saying that the gradient of a line is given by y2 minus y1 out of x2 minus x1. So again, you only have to indicate the coordinate and do the normal substitution. So from the formula up there, m equals y2 minus y1 out of x2 minus x1 is for the gradient of a line passing through two distinct points. Let's try to explain some few principles about the slope. Now, when we look at the first one, you will see the x moving from positive to left, right. I've marked there like marking an exercise book. You have that diagram over there. I normally call this as a positive gradient, because anytime you find the gradient of such a line, your answer must be positive. The diagonal you see there, you see you have x moving up toward the positive side of the x. So you check this one, you see rising as x moves from positive toward to the right, left. To the left of the axis, and then to the right, you have positive. So now I'm moving from the left to the right, so I'm increasing. And so that will give you a positive gradient. Please note this part carefully. Anytime the line rises as x moves from positive left to right, that will always give you a positive gradient or slope. The reverse, let me refer to that one as 2. The second one, you will see the difference between the first one and the second one. As the first was moving to the right, as it is rising, This is moving to the left as the line is also rising up. And so you can have it as rising or falling. They are the same thing. The difference is that one is moving to the right and the other is moving to the left. If the line is moving or rising to the left, then it means that the gradient of such a line will always be what? Negative. If the line is moving or rising up towards the left of the x, then it means that the gradient of such a line will always be what? Negative. Then the third one, you have a nice horizontal line there. Let us try to apply the formula to this one so that we will understand why it is 0. If I do indicate 2 points on that line and I trace them to the x-axis, yes, I'll get x1, all right, I'll get x2 there as well. But because the line is horizontal, the y1 and the y2 all be at the same point. So if you have y2 minus y1 and the value there is, let's say, 5, then you have 5 minus 5, which will give you 0. So it doesn't matter the value you have at the denominator, which is the x2 minus x1. You will still have 0 over a number. And then 0 over any number is always what? 0. So anytime you have a horizontal line to the x-axis, the gradient or the slope of that line is always 0. It's always 0. This is because the difference in the vertical distance, that is the y2 minus y1, will always give you what? 0. Always give you 0. Then the last one, very, very important, a vertical line. Let's apply the same principle in the gradient formula. I'm going to indicate 2 points on the line. If I trace them, I'll get y1 and then y2. y1 and y2, like that. But when you trace the 2 points to the x-axis, all the 2 points will come back to the same point on the x-axis, which simply implies that when you have any value for the y2 minus y1 for the numerator, the denominator becomes 0 because you have same number minus itself. For example, if I have 2 there, it will be 2 minus 2. And so x2 minus x will give me 0. Or we all know that any number out of 0 is always undefined. And so when you have a vertical line and you are finding for the slope or the gradient of such a line is not defined. It's not defined. And so now we have 4 options. We have positive gradient, negative gradient, 0 gradient, and then undefined gradient. We are saying that if the line is rising up towards the right, the gradient will be positive. If the line is rising up towards the left, the gradient will be negative. If the line is horizontal to the x-axis, because the line goes to the same y value, the vertical value will be 0, and therefore the gradient of that line will always be 0. Doesn't matter how the length is, it's always 0. And then when you have a vertical line too, the gradient is always undefined. I've explained that it is because the line passes through the same x value. Gradient is about y over x. So if your x is 0, it means that you get a number over 0, which is undefined. And therefore, vertical lines has got undefined gradient. I hope you get the interpretation of the slope on this part. And so you have this one to sketch. We all know how to plot points and then how to find for distance between 2 points. Sketch a line through each pair of points and find the slope of each line. And so I'll skip the first part, plotting and sketching. My main interest today is to help you be able to find for the slope of a line. So a line is passing through the point neg 3, neg 4, 3, and 2. How do you find for the slope? B, neg 2 and 3. 1, negative 3, that is the B part. C, a point neg 4, 2, and then 3, 2. and then D, a 0.24, and then 2 -3. I'll answer the first two, then you try the last two on your own, just to test yourself that you're okay with the concept. Solution. Gradient is equal to y2 minus y1 out of x2 minus x1. So by substitution, for the first one, A, x1 is -3, y1 is -4, x2 is 3, y1 is also 2. So by substitution, you have 2 plus 4 out of 3 plus 3. That will give you 6/6, and the final answer will be equal to 1. So the gradient between A and B from the example will be 1. And that of the B, you can see the sketch there. So the point is 3, 2, and then -3, -4. It should be -4, not +4. Good. And then for the B part 2, you have it there. The point is -2, 3, and then 1, -3. You see how the line is moving. It is moving up towards the left. So the gradient will be what? Negative. And so when you go by the formula, you have m to be equal to -3 minus 3 out of 1 plus 2. And that will give you -6/3. And the final answer will be equal to -2. That's the gradient. We had negative because the line is rising up towards the left of the x-axis, and therefore that will result to a negative gradient. So you can try the C and the D. Your answer must be equal to 0. And the D2, your answer must be equal to undefined. Undefined. You have these 3 examples to try at home, and then to be sure of yourself that you're okay with the concept. First one, find the distance between the point P, 1, 7, and Q, -5, -2. 2. Find the gradient of a line passing through the point A, 3, 7, and B, 10, 4. The last one is find the slope of the line AB. So you have a diagram there. A is 10 and B is also 4. Hint, if you have a point on the y-axis, obviously the x-coordinate is 0, and a point on the x-axis implies that the y-coordinate there too is also 0. You can go ahead and find for the slope of such a line. You have enjoyed the whole lesson today. Now you can say to yourself that when I give you any 2 points, you can find for distance between them, and also find for the gradient of such a line. This is Senior Study Class on TEK TV, one of the most authoritative educational programs on TEK TV. Please always stay connected to the TV, and you will enjoy a lot of lessons in mathematics and other subjects as well. Be good, feel okay, and work mathematics with all interest, and you'll be fine. God bless you. See you next time again.